Hey there, welcome back to CMTEQ channel. In this tutorial on how to design a simple analog to digital converter. So this is tutorial part 2B. In the previous tutorial we saw how we could add a 7-segment display onto our existing circuit to basically display the analog voltage onto the display. Now in this tutorial I'm going to show you how you can add an LCD display onto your analog to digital converter design. So if your project requirement is to have an LCD rather than a 7-segment display, then make sure you follow through to the step of this tutorial. So let's get started. As you can see, I've removed the 7-segment display part of the circuit. Now let's go ahead and add the LCD onto the circuit. So it's LM016 display part of the optoelectronics, and we're going to bring our LCD onto the circuit. Now all we need is to connect power to the LCD, so that will be VDD, okay, and we need a ground connection for our LCD, okay, so that will be VSS, and usually RW must also be pulled to ground. Now as always, it is better to connect the LCD in 4-bit mode, that way we don't have to use a lot of circuitry. So I'm going to use my Arduino pin 2, 3, 4, 5 and 6 for the LCD. So let's do the connection. Great, so this basically means my RS pin is connected on pin 2, enable pin is on pin 3, and D4, 5, 6, 7 are connected on pin 4, 5, 6, 7 respectively of my Arduino. So all I have to do now is to change my code and use the LCD crystal library and make sure I pass in the correct pins for my LCD. Great, so we open up our original code where we basically were just controlling the Arduino duty cycle to get our analog to digital converter going. So now the goal here is to display the duty cycle value and the voltage value onto the LCD display. So to do that, we're going to make use of the Arduino liquid crystal library. So I'm going to go ahead and paste my library here. So basically include liquid crystal, then I have to pass in the correct pin as I have mapped them from my LCD display here, as you can see. So basically pin 2 is going to RS, pin 3 is enable pin, and 4, 5, 6 are for my data lines. The next thing here is to basically declare some variable for my voltage and the duty cycle. So I've got the float volt and the duty cycle also declare as a float variable. Then we get into the setup library. Now we don't have much to do here because we only have to initialize our LCD here so that we can tell the LCD library what kind of LCD we are using. Now we are using 8 by 2, right? So which means we got 8 columns and 2 rows. So that's the only initialization we have to do. Now we move on into the void loop. Great. Now before we do the void loop function here, which is crucial for our experiment here, please make sure if you find this tutorial useful, you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. So I'm going to create some space here and paste an important piece of code here, okay, and we're going to go through the explanation of this code. So the line number 19 here, what we are basically doing here is we taking the variable that we declare here, duty cycle, and we then taking the value here. Remember, this value is the PWM value that is being written onto pin 19, right? So this value is being incremented from 0 to 255. So we then take that value, we divide it by 255, and we multiply it by 100. So what does this mean? When this value is 255 and we divide it by 255, it's going to be equal to 1. And when we multiply 1 by 100, we're gonna get 100%, right? So our PWM value is gonna show 100% when value become equal to 255. So that's basically what we are doing here. Any number less than that is also going to display on our display as a form of a percentage. Great. Now we move on into this line here. Now this section here is to basically display the duty cycle value. So first we call the LCD to set the cursor. We want to be on the first row. Then we want to pass a string duty. Then on this line, we are remaining on the first row, but we are moving on column number 8, right? And we are passing the value of the duty cycle plus the percentage symbol. So that basically all we are doing here. Great. Now before we get to the delay function, we then need to compute a piece of code that will basically compute the voltage that must also now be displayed on the LCD display. So what we are basically doing on line 26, we calling the float variable volt, and we passing the value that must come from the map function, right? So we're calling the map function and we're taking value, because remember, we depend on whatever the value is being incremented there. So we then map it from 0 to 255, which it is already, and we then also map it from 0 to 1000. Then what we do is we divide it by a float value of 100, right? So that will basically give us whatever this value of PWM that will be mapped to a 0 to 1000 will be divided by 100 float. Then this will basically allow us to capture even the decimal values. Then we repeat the LCD code here to also just display the voltage onto our display. After that, we then get to the delay function. Now all of this code is now also going to be repeated when we decrement the PWM value. So I'm going to just copy it, right, and then just paste it here, because it's the same piece of code that must now also be executed as the PWM value is going to be now decremented. Now what you can do here to avoid code repetition here, because we're basically repeating the same line of code, you can go ahead and optimize these by creating a function. Let's go ahead and create the function void LCD underscore handle. Basically this function is going to handle the LCD display for us. So what we have to do now here is to basically just copy all these line of code. So we're gonna just cut it from here and paste it here, right? Then we don't need this code here on our second loop. We can just remove it. Okay, then we need to pass the function parameter value, because value is being basically declared here in our for loop. So we need to create a parameter of type integer, and we can call it whatever name we want. We can say PWM val, right? So PWM val, then we need to pass the PWM val into our duty cycle computation there, and also into the volt computation. So that basically what we need to do here. Now we can then go ahead and call the LCD handle function, right? Then we need to pass value, right? So we cannot pass PWM val. We now need to pass a function parameter as value. So that basically what need to happen there. So I'm going to go ahead and just copy the same line of code and pass it here right there. So now this will eliminate the need to basically repeat code. Now let's go ahead and build this. So if everything is fine, we should have no error reported, right? So the code compilation is completed and there is absolutely no error. So at this point, all we have to do now is to load our binary or hex file onto the Arduino. Great. So our Arduino file is pwm underscore DAC underscore LCD. Now let's go ahead and navigate into the folder so that we can actually find our hex file and load it onto the Arduino. So pwm DAC underscore LCD, and we need a hex file. Let's pull it in, and okay. Now at this point, all we have to do is to basically just run this, and if everything have been done correctly, there we go. We should be having the duty cycle display and the voltage, right? So as you can see, with a duty cycle of 27-30%, we've got a voltage of 3.5. Incrementing, actually it's incrementing faster, we cannot keep up, but you will realize that at a duty cycle of 100, we should also have a voltage of 10 volt or so. right? So 70%, 7.4 volt, 80%, 8.1 volt, and you can see that the analog to digital converter is indeed working. So at every duty cycle incrementation, we've got an analog voltage corresponding to the specific duty cycle. So this is how you can do this and implement this onto your specific project. So thank you guys for watching. And once again, if you find this tutorial useful and helpful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. Stay tuned for more tutorial of this nature. Until next time, cheers.